Okay, so last time we wrote this program to generate a list of x points, but our main goal is to be able to plot functions. And so now we need to calculate the corresponding y points, which is actually super straightforward. And we also want to learn how to plot these functions on a graph. So again, we want to make inputs and outputs. If we want to just plot a simple function like y equals x, a line, if you double click, by the way, you can make these little text boxes that are just that don't do anything in the code. They're just labels, so you could label your code and what different parts of it are doing. But y equals x, where our y value is just the same as our x value, that's just a line. What if we wanted to plot that function instead of just display a list of x points here? So you can make graphs on your front panel. If you right click, go to graph, you want to go to XY graph most of the time. Place that down. Looks like a graph. How do we display our line on it? Well, you see we created a corresponding object on the block diagram here. And the type of data this accepts is what's called a cluster of two arrays, an array of your x points, an array of your y points. Now, if we're plotting a line, then our x and y points are the same. So I can just create, another indicator here off of the same wire. And I can call it y points, and that would be an accurate description of the y points. It's just exactly the same as the x points. And if I run the program, you can see that we're indeed generating x and y points that are the same. And if we want to graph those, we want to bundle the x and y values together. If you right click on the block diagram, go to cluster, class invariant, go to bundle. You can kind of combine multiple wires into one. So we'll take our x points here, and we can do the same for take our y points. And it is important the order you do this in. You want the x points on top and the y points on bottom if you want your graph to display correctly. Wire that into your XY graph. Run the program, and we have a line plotting between -5 and 1. X min is -5, X max is 1. Points is 4. If you want to see the individual points, you can change the plot type here. Go up to your legend. Easy way, go to common plots. Instead of just the continuous line there, you can click on the points. So now you can see our individual points there. And if we increase our number of points we want to plot, you can see we get more and more points appearing on the graph as well. Okay, so super useful, super common. You can relabel these axes if you want. I'm just going to call it X and Y. I don't really like these grid lines on here. You can turn those off if you right click on the graph, go to properties, and go to scales. For x-axis, it's asking you what the grid style should be. Just click on this option without any grid lines. Do the same for the y-axis. And there you go. It's a little bit easier to see what's going on now. Okay, so we can plot a line. That's easy. What if we wanted to do a different type of function, or maybe just start off with a different type of line? What about y equals 2x plus 1? There's your classic y equals mx plus b line function. Well, instead of just using these same values as y, let's delete all these wires here. can see that broke our program there temporarily. No big deal. I'm going to make another loop here. And we're going to take each of these x values in our function and calculate the corresponding y value. So if I wire our x points in as an input to this loop here, then I can multiply that by m. And in fact, I'm not even going to put numbers in here. I'm just going to put variables in here. mx plus b. So let's create new numeric controls here so that we can plot whatever type of line we want. There's m. There's b. So we want to take our x value, multiply it by m. And then add b. You do want to make sure you go by the order of operations here. Otherwise, you'll be plotting something else. And put that in x points. Now, another thing you'll notice here is that when you wire an array up to a loop, on the input side, it gets thinner. And then, like we talked about in the last video, on the output, it gets fatter, and it gets fatter here because it's going to take whatever this value is for every iteration, every time this loop runs, and put that number in a list. So what it's doing on the input side is it's taking every number in your initial list and going through that list using the next number in the list every time that this loop runs. So you'll notice when I do this, I don't actually even need to specify how many times this loop is going to run, because it's going to run a number of times equal to the number of points in this array. Okay, so if I make points up here equal to 3 again, it's going to generate a list of 3 x values, and then this loop is going to run 3 times, one for each value in that x points array. Multiply each one by m, add b to it, and we'll get our corresponding y points. And I'm going to go ahead and put that into our graph again. So when I run that, and let's go from x min equals 0, x max equals 10. Let's do a slope of 1 and a y-intercept of 0, because that's just our normal line. So here's our line again, going from 0 to 10. And if I change the slope, it should get steeper. And indeed it does. The numbers changed, you can see. The x and y axes auto-scaled, so it's not like you couldn't see a visible steepness change there. But what you can do is you can change your x and y scales to whatever you want. And then just to make our changes more visible here, I'm going to turn off the auto scale feature on both axes. And so now if I were to change the slope back to 1, you can see that it is actually changing. You can go to 0.5, make it a less steep slope, and so forth. And I'm going to go back to plotting just the line. And what if I change the y-intercept? Is this working right? If I change this to 2, then this whole line should shift up so that it starts at 2 instead of 0, which it does. Okay, and if you want to be able to change values without kind of clicking run every time, if you want to kind of update automatically, you can click this button to run the program continuously over and over and over, so that it's going to automatically refresh when you change these values to see how that affects your resulting code. So that can be really useful. But now we've made a program that can calculate a line of any sort. You can do the same thing with any type of function. So what if we wanted to do a parabola? So this, if this was x squared instead of x, we can still change the steepness of the parabola and move it up and down with that b value. Well, then you would want to, instead of just doing m times x, you'd want to do m times x squared. So I'm going to insert into this wire from the numeric palette a square function. So now we're going to do x squared times m plus b. And you can see that we're getting half of a parabola here. I need to plot some negative values if I want to see the whole parabola. And remember that my auto scale is on, so let's change this to -20. Doesn't look too much like a parabola because I'm using a really small number of points. So I'm going to use 60 points. And there you go. Now we've got a much better parabola. And I'm going to zoom in on that. And that's exactly what you'd expect a parabola to look like. If you change the m value, it changes how quickly that rises. And if you change the b value, it shifts it up and down. What if I wanted to shift it left and right? Well, that function would be taking your x value here and subtracting from it the x shift, which I don't know what variable name is typically used for that. We'll call it n. That will shift it to the right by n points. And so what we can do is insert our, let's just create a subtract. So we're going to subtract n from our x values before we do anything to it. Let's make a new input, which is n. And it doesn't actually matter if you put that inside or outside of the loop, just for aesthetic purposes. I kind of want it inside. And let's organize things a little bit. Now when I run it, you can see that this n value shifts it left and right. Okay. So you can make any function this way. You just replace the math here with the math for whatever the function is that you want to do. You could put a sine function in here. You could put a polynomial with, you know, square and a third order term and so forth. Doesn't matter. You now have the power to plot any function.